We are recording now. This is meeting number 5 of the scicloj series of meetups around AI, enclosure. Today, we will have 3 speakers, Pragyan and Vedang and Siavash. And this part is recorded, but maybe some parts of the meeting will not be shared publicly. Later on, we'll figure that out, and as we always do. And we will have a relatively long meetup with 3 talks and then a discussion. And we are 8 people at the moment. A couple of more people will join soon. So maybe we'll begin by asking anybody to say something about themselves if they like. And oh, great. Hello, Siavash. Yeah, maybe Olaf, is it okay to ask that you would say something about yourself, about who you are, what you care about, and so on?
Yeah, sure. I'm Olav. I'm working with AI in public sector in Norway, and yeah, I'm pretty interested in everything to do with LLMs and whatnot, especially with connecting LLMs to live programs. Yeah, that's something I'm really interested in. Yeah.
Yeah, thank you so much. Hello, Henning. Would you like to say something?
Good afternoon. I'm Henning. I'm also from Norway. I work part-time commercially, sometimes full-time in closure in public transport, maritime industry. Work with and around.
Oh, did we lose the voice maybe? Oh, maybe.
Maybe we did.
Oh, it's better now, yeah.
Okay. Yes, I'm Henning from Norway. I work in public transport, maritime industry with closure applications and working with data, trying to understand enterprise data from our domain. Working currently in Python for with the things that I need for day-to-day work, but trying to move that into closure space. That's me.
Thank you so much. Yeah. Hello, Phil. Would you like to say something?
Well, I understand that birds know how to use tools, and I use tools from time to time. And I've decided that LLMs are a tool that can use tools. That sounds like a meta tool. I'm interested in this.
Oh, that is so nice. Yeah, thank you. About myself, I'm Daniel. My background is mostly statistics and probability, and I'm a community organizer at the moment, at my free time that I have a little bit of at the scicloj group. Hello, Michael. Would you like to say something about yourself? So nice to meet you.
Yes, of course. Good afternoon to everybody there. I'm in New York. So I'm a research scientist at LexisNexis. Work specifically on AI and especially AI in interaction with humans in the context of building legal AI assistants. My background includes philosophy and computational cognitive science and information retrieval. So my interests, as I said, are really focused on composing these systems with an interaction with users. And obviously, LLMs are having a big impact. I use Clojure just as research code. We're a Python shop at the end of the day. But I'm trying to get people to think more functionally. So I'll leave it there.
Wonderful. Thank you so much. Yeah, and maybe hopefully one day we'll ask you more about that if you would like to tell more.
Yeah, when the time comes, I'm happy to share, the degree to which I can. But I'll just underline that right now this is really research, but it is something at the rate that things are moving, it could turn into applications and stuff that gets into production pretty quickly. we'll see. AI is moving so rapidly.
Yeah, thank you so much. Hello, JD. Would you like to say something about yourself? Oh, I'm unsure. Yeah. And Tori, I know maybe it is inconvenient for you to speak because parenting and so on. So if you wish, you can write something about yourself. Or anybody who wishes to write something, you're very much invited. And I'll share the link to the Zulip chat, which is the permanent chat for this meeting. I'm sharing it again here in the Zoom chat. And yeah, so we will now begin with the speakers. And maybe Pragan, would you like to say something?
Sure. So I'm Pragyan, and I'm building a company, Wade AI, and we enable people to build websites in multilingual, like multiple languages, and that's what our current focus is. And while building it, we have discovered certain patterns, like how to use an LLM APIs effectively. And that's what we are like going to talk about today, like whatever our experience has been in the last couple of minutes. That's me.
Fantastic. Thank you so much. Yeah, and maybe Vedang, would you like to say something about yourself?
Yeah, I'm Vedang. I have almost my entire professional career has been Clojure, and because of that, I'm very interested in like taking the language forward in any way that I can. So that's the reason why I wrote the MCP Clojure SDK. Also, I feel that understanding the internals is really important to like opening a new perspective on what you can do with this technology. So it was the easiest thing for me to approach because I am a distributed systems person, and this seemed like a distributed systems problem. And therefore, it was a lot of fun to do that tinkering. In my professional life right now, I am the founder of a consulting company, a software engineering consulting company, and we work with people who have web development scaling issues. And I am hoping for being able to use as much Clojure as possible, but at the moment it's my personal and private projects mostly. But before this, I was professionally working on Clojure for 15 years close to.
Thank you so much. Yeah. Yeah, and maybe Siavash, would you like to say something about yourself before we start with the talks?
Hi everyone, I'm Siavash. I'm working with Clojure for about 5 or 6 years, and currently I have a project in Clojure, the BI project, which I'm going to share some part of it with you today. That's it from me.
Wonderful, thank you so much. And JD, if you wish to add anything.
Hi, I'm Jed. I have finally fixed my Zoom. So Daniel and I had a little bit of trouble with this on Monday. My name's Jed. I've been interested in Clojure for a long time, but kind of sporadically, and I'm interested in spending some time getting into the internals of the language, getting into just developing doing some work with building some libraries. I've been a software engineer. I just finished graduate school in computational biology, so I'm also interested in the data side of things, and I'm also really interested in the way people learn and in the way you teach people. So kind of bringing people along and saying, this is this big scary language with all these parentheses. It doesn't have to be that way. It's actually a lot easier to learn than JavaScript, say, with that double equals operator. So I think that Clojure is a really interesting language that has like a lot more to offer in terms of like cognitive benefits than most people realize. So that's why I'm here.
Yeah, thank you so much. Great. So we'll now begin with the talks. And as we said, maybe this will not be one video. Some part of it will be shared unlisted on YouTube. Some parts may be public. And I think we will begin with Pragyan, if that is okay. If you wish. Yeah, thanks so much.
So shall I share?
Yeah, yeah.
Okay.
Yeah, so this I think will be something like 20 or 25 minutes, if that's okay. And if you wish, I
Yeah.
can tell you a little bit before, and then we'll have
Yeah.
questions and move to the next speaker. Thanks so much.
Absolutely. Sounds good. Sounds good.
Great.
Okay. So let me start sharing. Just a disclaimer, my laptop works very erratically whenever I'm sharing screen, so I'll just like try to work around that. Is my screen visible?
At the moment, it is blank, like one black rectangle.
Okay. No?
Oh, yeah, we can see.
There
your
we go.
screen.
Oh,
Yeah,
perfect.
thanks.
So, okay, so what I wanted to talk about, so we are building Wade AI. Wade AI is a no-code platform to build multilingual websites. And let me just first start with the demo itself, and then we will go into how we are like enabling that whole thing and how Clojure's simplicity helped us do that whole thing in a very simple manner. So this is our app, which is live at wadeai.app. And suppose you give it a prompt, develop a podcast landing page in French, and you can just click here on, let's see, if there is anyone who wants to have like, if someone has a language preference, I would like to add that. No, so
I understand Marathi, so if you could use the
perfect.
Marathi, that'll be great.
Good, perfect. That would be nice. Marathi. So it's like creative writing. Let's see what it does. So it's always a surprise whenever you use LLMs to generate a UI. Let's see. Yeah. So I hope demo, like gods of demo, don't like screw me today. I have been testing it all the time, but let's see today. Yeah, okay. So it started building based on the prompt which I have generated. So not that accessible, but anyways. So based on the prompt, what it is doing under the hood is like it takes up that prompt, and we are calling Anthropic's LLM API to use this particular prompt and then start generating the operation to generate a UI. And how it happens under the hood, because it takes some time with Anthropic. With Gemini, it becomes like really fast. So we'll come back to it later on, but this is how it is building a website in your language. And one of the major thing is because it's a no-code platform, and so language does not become a barrier for you. And in that particular language, you can just interact with the whole platform. So yeah, that's what we are building. And let's get into how we are building it. So there are three major concepts here in play. So one of the core thing is our get to this, yes. So one of the core thing is we have a unified interface to interact with multiple API providers. So be it Google's Gemini, be it Anthropic. So what we have done is a protocol based like a unified interface, where for each API provider, we have created this unified functionality to generate a content or to generate a stream or like asynchronously generate or attach a media, all these kind of things. So what it enables us to do is like I can change the multiple providers. I can do A/B testing. So in some cases, Gemini works better. In some cases, Anthropic works better. So this is a demo for that. It's like, for example, I have just given it, this is going to be my provider, and I'll get the Gemini provider from it. And then there is the Anthropic provider. And once we start demoing it, let me just call this function. It will call the same prompt on 2 different API calls, and then I can test which one works better for me. Is the font size fine? Is it visible? Everyone? Okay, perfect. So
yeah, I think so. Yeah.
this is what the Claude's response. Perfect. So okay, so this is what like Gemini's response would look. This is what the Claude's response looks like. And this is where like a unified interface helps us a lot. Based on like I can keep adding more and more providers, keep testing things out, and we have exposed it to the users as well. Like the users can bring in their own LLM providers when they are generating the app, like generating the UI for themselves as well. Now, the next part is just to demo the streaming part, that how the streaming would work is suppose there is this generate stream function. It's a unified function which works on both the things. Let me just show how it would work here. And yeah, so just a second. Okay. So consume stream is a simple function which is taking up each chunk of data from the LLM API and then concatenating it and printing it like this. So this is what the story would look like whenever you are printing. But it took us a lot of time to understand is like how to make it much more functional, and how we can like handle this stream in much more functional way. And that's where the concept of folders became much more important for us. So this is where like I start admiring Clojure much more. I wouldn't have even understood like the folders concept. So just to reiterate how the folders work is, a folder is a simple function with 3 kinds of arity. With 0 arity, it's an initial state. With 1 arity, it's a final state. And with 2 arity is a accumulation state. So as soon as we are getting a stream of data from the LLM providers, what you can just call this particular function and it accumulates the data. So you are not, so it becomes memory efficient overall. And once you start adding these kind of stream processing within your generate stream function. So how we have enabled that is a very simple parameter. So suppose we have, I have a function here itself. So let me just show you the example I had talked about in the blog post itself. So yeah, so this is one of the function. What this does, let me get it a little bit more. Okay. So this is a generate stream function. What it is going to do is like generate 10 JSON objects with name and age key in it. So this is the kind of thing we want. And what LLM is doing in this particular state, it is streaming the data, it's streaming the whole JSON, but there would be different kinds of strings beyond, like across that JSON. So this is the kind of output we start getting, like 7, 6 objects. So as you can see, there is this JSON object, and all these like what we want from this stream of data, we want to extract these JSON only. Like these are the structured information we want from a stream of data. So the problem with LLM providers has been, when you want a structured data, streaming is not possible. So as streaming is not possible, I cannot have a faster experience in our application. So in our application, the demo which we are seeing, like as soon as the operations are getting generated, we are able to render it immediately. So the experience becomes like much more smoother. Okay, the work is happening. I'm not waiting for a minute overall and then getting dumped with everything at once. So it progressively keeps showing what kind of operations are generating, and they are getting applied in a streaming format itself. So because of that, what we wanted was, okay, I want the streaming, I want structured JSON, but in a streaming output. That was my overall goal. So and that's where like folder starts helping me. So this is a simple function which was like rendering the overall content stream. Now we have this parse streaming JSON, and it's a folder function. Let's go and see what it looks like. It's a very simple function. What it does is it takes up a content whenever I'm getting a content. And what I'm doing is accumulating whatever stream I'm getting. And based on whatever the string value I have, what it does, it tries to extract the JSON from that string. How the extraction happens, we'll get into that just after we understand this folders concept. And these extracted JSON are passed into the parsed object, which you can then read and start streaming to your UI. So just to demo that functionality, this is what it looks like. Okay, I'm calling a generate stream function. Gemini is my provider. These are my messages, and you have to process this stream by using this particular folder. So this is a folder, and let's just let me open a portal here so that the output is a little bit better. Yeah. So yeah, so this is what it is doing. This was my overall content. If we just see it in Markdown, this is what it looks like. There is like a JSON embedded within the text. And we have processed that whole string and found all the structured information which was there as a JSON. So, and what happens, it does it progressively. It's not like, okay, it's waiting for everything. Like you can write a function as soon as I'm getting an operation, send it to the client. So that's what we have done while doing it. But the folder currently is just like, it is just accumulating all the structured information in the past object. And this is what this whole thing looks like. And this simple concept has helped us give like much better experience while the UI is getting built. And the user doesn't have to wait. The only con of that is overall time, if you see, is much more than like a response format. If you see, okay, I want a response format as JSON, the time it would take would be accumulated time in that particular case and accumulated time when you are processing that stream. The process, when you are processing the stream, it would be much larger than like using a response format. So if you are okay with like a single short API call and you want a very small JSON to be output, then it is fine. But it becomes much harder when the whole UI needs to be generated and you need to do like multiple operations in one go. So what we are optimizing for is like a time to first JSON, time to first operation. So, and accumulated time is much larger, but for time to first JSON becomes like much shorter when we are doing it like this. So this is like, okay, we understood, okay, there is the unified interface which enables us to talk to multiple AI providers with a single interface, which speeds our overall development process. There is this concept of folders which enables us to handle like stream of data by just writing simple functions. And it's very like composable. I can just change the function and the whole stream just works very differently. Let me what there should be some other function. Let me just get another function because autocomplete won't work. Yeah, join streaming content. So just a second. Damn it. Okay, so join streaming content. Let me just join streaming. Oops. Content. So what this is going to do, this just gives you the final content. It is joining, so it is not doing the parsing thing. You just change the function you're processing, it will change. So, and let me just get to this part. Let's see how it is. Yeah, so this is what we are getting. Like this was the string which we saw previously. And you can use a map, you can map through it and you can write your own folder, your own folder. So process these kind of strings, and we are not like, and it becomes like it's memory efficient, it's fast, and all these things are already in place. Now the third part which we have discovered, okay, before that, let me just get into, okay, how we are parsing JSON. So, and here we have a JSON extract method. In the blog also I have like talked about it. So previously I was using like a normal regex and it was a pain to deal with. It's like, okay, how to write that JSON, okay, so that I can get JSON from these kind of random text. So sometimes there would be escaped character, sometimes there won't be an escaped character. So getting that regex right was like really hard. And I already knew about instaparse, but I used Claude's information to generate this grammar. And as soon as like this is what enables us to extract JSON from a random set of strings. So what this does is like there is a non-JSON string, there is a JSON string. Then I figure out, okay, JSON could be an object type, it could be an array type, and then how the value is there. So it's a very simple way to describe the grammar. And not only that, I can use now instaparse to define different kinds of grammar. So I can like I have done it for like XML format as well, because I was trying to see, okay, how to make it like much more reliable. So just writing a simple grammar, it started extracting like a XML data into a JSON, into a structured information. So that was like quite interesting for me. So this is like a simple function which does that. There is this transform map in the instaparse you have to pass, like as soon as you get particular data, how to parse this information, that kind of stuff. So this is a very simple function which helps me figure out like structured information from this streaming text. Now, once that part done, like the final piece of the puzzle took us like some time. So the UI you saw, it's not a single API call. Because it is generating, for example, so LLM API calls have a limit to the output tokens. And in a single API call, I cannot have like all the operations available. So what this enables us to, like, we have to build an agentic workflow. So what we need to do is like, okay, I built a hero section. My hero section looks like this. Now let's go and build a features section. Now let's go further and build something else. Now go to something else. So this is the kind of flow we want till my whole goal is achieved. So to do that, previously, perfect, like a really good UI built just by a single prompt. But yeah, so now to do the final piece was, let me just get to that. Yeah. So the first iteration we built was we started using Clojure async flow, but still the managing like all the processes across, it's like, okay, how the iteration would work, all these like async process, management of async process was getting really hard. And so the 2 weeks ago, we came up with the pattern of using iteration method. So Clojure 1.2, Clojure 1.12 has this iteration method, and I was always figuring out, okay, how to use it best. People generally give the example of using it for pagination of the API calls and everything, but I ended up using it for like agentic workflow. So in agentic workflow, we need to define in each iteration what to do and how to accomplish a goal. So in this particular thing, like I have an example of a story builder. So I'm using Gemini's API call because it's free. And then there is this step method. So in this step method, I'm saying, okay, my goal is to generate 4 paragraphs or like 3 paragraphs, whatever. And till then, you have to write a story. So, and it needs to be a continuous story, that kind of thing. So so let's see. So this is a step function. In each API call, I'm calling this generate method. And in this, based on like continue this story with the next paragraph and everything. So these are the tricks which I was using like to maintain the context across API calls. So LLM APIs, I would ask LLM APIs to generate a summary of what it has done and what kind of UI it has generated, and then pass that summary as a prompt in the next API call. And the overall output which you saw is like very much consistent with the design theme it followed. It is happening because of that. Like we are using summary of one API call as an input of the another API call. So in this particular case, as you can see, this is a simple iteration method. This is my simple agentic, like in agentic flow, I need to just define, okay, how to do this one process, right? And that's it. That's the only thing I need to do, and my agentic flow works. Let me just show it like this. Oh, okay. So this is, I've loaded this, and let me get to that. So iteration gives you a lazy C, so lazy function, and then you have to like reify it into like call next or into a vector. Let's see whether we get the output. Yeah, so this is the output we got. and of each paragraph. So in the next story started like this. Then what we are doing in this API call is like we are concatenating. We are always outputting the updated story. So this is what it looks like. Let me just, so iteration 1, let's go into this. And we don't need that. So this is like, okay, unsettling aura of the unknown. And in the next iteration, it will build upon that. Aura of the unknown, a chill, colder, than like that. So it is just building up the story in each iteration. And then the overall story is like on the third paragraph, it just generates the overall story. Now, like the benefit of these things is currently I'm calling value function as identity. That's why we are getting a vector. But suppose I wanted the final output itself. That's the only thing I want. So I'll just replace this whole thing with the story. Like I want the story itself. That's the only thing I want. And let me just call this.
By the way, Pragyan, we have time, no rush, but it would be good to maybe conclude in a few minutes, if that's okay.
Oh yeah, absolutely. So it's the final function call. So we're already done.
Thanks.
So let's just get to the story builder. Did it work? Yeah. So this is what the final story looks like. So what it is doing is like it iterated 3 times, and then the final story is just output, is the output of that iteration function. So this is the way we are building our whole UI, that we define a rule, we generate structured information from the streaming data, and then we figure out, okay, how to complete a particular agentic flow. And all these decisions are taken by an API call. And yeah, that's it. So that's our overall progress and the patterns which we are using under the hood right now. Any questions?
Yeah, thank you, Pragyan. And yeah, so we have a few moments for questions. And by the way, hello, Danielle, and hello, Ovi. Great to have you back, and congrats on the big adventures. And yeah, so we have some time to chat before we move to the next talks. Any thoughts, any brief questions to Pragyan?
Yeah, can I ask, Pragyan, was this technique inspired by the cursor or like all agentic providers now, the slash compact feature where you go into a branch so long that it starts to hallucinate, so you just say, let's just compact and summarize this whole thing and start again from that point?
So actually, there was a webinar by Claude's people. Like one of the developer was just talking about, okay, I'm using Claude code to do certain things, and suppose it's like hallucinating. I'll just ask it to summarize it, and I'll use that summarize for the next instance. So I was just like, okay, I use that particular thing. Okay, let me just summarize the overall thing which I have done. And then the output became like much more consistent all across. And I was like struggling to make it consistent quite a lot. But as soon as you start doing these kind of context management, it works beautifully. So.
And you mentioned that is, if I understood correctly, that initially you used the new correcting flow.
Yeah, I did.
Library to do this. And what were the limitations? Indeed, you cannot have something like this where in the next step you bring history. I mean, you kind of can if you keep a state in one of your processes, but I'm curious, what were the hurdles?
That was my goal itself. It's like I wanted to have that previous state, but it was just becoming much harder for me. So my previous implementation was, okay, I'm going to have like a development team. So I wanted to build like a project manager. It was like one co-racing flow process. Then there was like an app generator. Then there was a designer. So, and there was a section generator. So all these 4 flows were like interacting together. And like the output, I wasn't getting like, because I was losing the context in the middle somewhere. Like sometimes the JSON parsing would fail. Sometimes it might not generate things right. So it was just difficult for me to retry then and there. But in this particular case, as soon as I see a failure, I just say, okay, discard the previous iteration, retry. And then the overall thing becomes like much more consistent. And it's just a single function rather than me processing everything together. So that, but the benefit of that was async flow was this whole, I understood about folders concept. because the process are defined like that, singularity, doublearity. So just by understanding that, I understood about the folders, and then how I can enable this whole streaming asynchronous flow. So currently I'm using direct like async channels itself for streaming the operations, and that's it. And this particular iteration function for generating the operation.
Great.
First of all, congrats for the kid. So
Thank you.
Yeah, let me, if I can, I'd like to ask what I think is kind of a follow-up question. So I'm very interested in the problem of context.
Yeah.
And, above computing context, really semantic context and producing something that is, for example, coherent from, let's say, a point of view, something along those lines. Can you, so what I've heard here, and please correct me, is the sense of keeping the same context is connecting the steps which are related to one another. And again, make sure that I have this right, so that the context in some sense is just being pulled through, it's being connected.
Yes.
And one of the opportunities, I think, I haven't really worked with Flow yet. It seems that one thing that Flow permits is the ability to inject knowledge into the steps, perhaps coming from some other place that itself could be a kind of context. Is that, first of all, is that picture right about what you're doing? And more generally, does it make sense to be thinking about context within Flow and within iteration that way?
Well, when I was using Flow, so there was, let me just, in my experience, I was using it like that only, but it was much harder to do, to maintain the consistent context. So, sorry, yeah.
Okay.
Yeah. So what I was doing was, for example, there is a project manager. Project manager will create a PRD. And based on that PRD, I would pass that context as to a designer. So designer will take that PRD and figure out what kind of pages I want to build. Now, so I got that PRD, and then, but my original context was lost in this particular case, original intent. So it, like, the hallucination part of other processes depends on the accuracy of the first process. So now, for example, the PRD is generated. Now my pages are there. So, okay, I want to generate like 4 pages. So for each page, I would go to a designer, okay, create this particular page. And what it would do is like generate a list of sections. For each sections, it would generate a list of operations. So this is how I was like trying to pass the knowledge in each flow, like in each process. But like it didn't work for us because I wanted to keep that history much more coherent. It's like, for example, if I have built 2 sections, I want the context, okay, I have already built 2 sections. But in this particular case, what was happening, each section was isolated. So maintaining that coherence was really hard in a like a flow-based
I see the problem.
Yeah.
And it's easy to see how the I guess what I would characterize as style of each of the outputs would benefit from going to the strategy that you're using here. Thank you. That's helpful.
So if things are like what my understanding is, if things are stateless, then it would work totally fine. But in our context, each API call needs to have that previous context. Only then it generates a consistent output.
If I may mention here, you can do it in coercing flow, managing state, and also asynchronously injecting into one processor context at not random times, but at whatever times that context comes in. Indeed, you could say it is a bit more involved than
yeah, exactly.
The example that you, or the final result that you have here.
Exactly. So this is and I got it to work, but it was like it was such a pain to just manage it and handle it and make changes to it. I was like, okay, this is not manageable for me. I need to change it. And when it's like I just went to, okay, how to the cloud. Okay, can I use an iteration method here? and then it outputted a single code. I was like, okay, this could just work. I just replaced that whole thing with this one function.
Again, I have one question.
Sure.
From the very beginning of your talk, have you open sourced your library for the abstraction over multiple different kinds of APIs?
Not yet. I'm planning to. Not yet. Yeah,
We are
absolutely.
desperately in need for something like light LLM in the Clojure world. I think
perfect. So
that
I'll
would be-
totally open source it like within this week. So,
Please do.
Sure. Absolutely.
You discussed a trade-off in terms of time between receiving a structured response and a stream of little structures. Did you
Okay.
discover any difference in quality? Is the result better if you keep the LLM on a short leash and issue frequent prompts asking for minor tasks? Or do you get better cohesiveness if you use a single prompt and get a single structure back?
So, one of my friend actually suggested it to me that LLMs are really good in generating small outputs. So it was his experience, but I took it as a grain of salt, and that's what I have seen. If you ask it to generate smaller outputs, it generates much better outputs. So you can keep adding more and more input to it, but if you keep the output smaller, it generates much better overall outputs. Like if you're putting it across API calls.
And did you find that JSON is more rigorously or less rigorously structured in one format or the other? Do you count on throwing away a certain percentage of responses that are streamed because the JSON is botched?
In format, yeah. So when I was generating large JSON objects, like that kind of issues were quite a lot. So yeah. So if you keep JSON much shorter, like it is much more likely to have it is structure, like the format is right. But as soon as the size of the JSON, like in my user prompt, I have specially told the prompt keep the depth up to like P level. That's it. Don't go beyond it. So, and that's when we none of the operations were getting discarded there. So smaller outputs are better, and it corresponds to the costing also. Is the output tokens are costlier. So I just use that for my own sake. It's okay, just to keep the cost lower also, it helps me.
Just a question from me. You might have answered this or presented this in the talk, but I'm curious because I see that, for example, this example you were using Gemini. Did you, or how do you compare results from OpenAI structured output where you can put a JSON schema on the output that you care about versus, because I'm not sure Gemini has a structured output syntax.
They do.
What Gemini gives your Claude.
The Claude doesn't have, but Gemini does have that.
Okay.
So you're asking in what, in terms of quality, in terms of response time?
Quality, being consistent with outputting correct JSON, things like this.
So OpenAI and Gemini, so in Claude, they don't have a response format as a key. You just, they recommend, okay, just ask it to return a JSON, it will return a JSON. That's what they have stored. But in OpenAI and Claude, you can just pass that JSON as a key. The issue with us is, they don't stream, you can just only get it in one shot. So all the validation happens there. And we want to show something to the user as fast as we can. And so time to first operation for us was considerably lower, but overall time in accumulating JSON from a stream is higher. Overall time in getting a JSON directly from an API call is much lower. So, but time to first operation is still much lower than. So user starts engaging with the overall UI. So that's what we start optimizing.
Yeah, we will in a moment move on to the next part of this call, unless there is something that feels so important now to mention before we continue. Any last brief comment by anybody? And if not, then we'll ask Pragyan, maybe you wish to conclude this part and say something before we continue.
So thank you so much for listening to me. Please let me know if any doubts are there, or any criticism is also helpful. Thanks for
The site was actually remarkably consistent. I was looking at the output that was being generated. It was really
Yeah.
nice.
Yeah.
Very well done.
Exactly. So I have like tested it quite a lot. So it happened just by changing that whole thing. And I was like, perfect. Just maintain the context.
Yeah, thank you. And yeah, thanks, Pragyan, for this great clarity of, just it was so nice to learn from you the whole session. And we will now say goodbye to this part of the call because the next part will be a separate video, unlisted. And so see you later on. So we're back at another part of this meeting number 5 of the scicloj-ai group. This part may or may not be shared publicly, depending on what the speaker thinks. And we have Siavash, who will talk about data analysis using LLMs. And maybe, Siavash, if that is okay, can you say something about yourself in the beginning before you begin your talk?
Hi, everyone. I'm Siavash, and working on a BI solution, and on that BI solution, I find some challenges and find some way to solve it. And now I'm sharing my solution, some part of my solution with you.
Yeah, thank you.
So let me share my screen. Let's go with the screen. Okay, could you see the slides?
Yes, we can see.
Great, great. Just for a second for slides to load. Okay. Data science, sometimes when you have a big data set, is like finding a needle in a haystack. Like, for example, you want to rotate data, slice and dice, using PCB analyzers and PCA, principal component analyzers, and so on to rotate data and find the way that you would a meaningful result, you get a meaningful result from it. I had a project, a BI project, a report server for some agricultural data. It has a near 700 tables, and each table has a huge number of columns, like 50 columns, 60 columns. Between some columns, there are geospatial relations. For example, one column has, one table has X and Y coordinate, the other column has a shape coordinate, and you can, maybe this entity is placed inside another entity, but it is not normal foreign key. It cannot be mapped as a single foreign key. And as a user can ask different queries, so it is not possible for me to have some hard-coded queries, and it was not possible to use another database except Postgres. So Neo4j is not possible, which maybe solve some of the issues. And as I was working on the project, I saw that even simple queries take time, joining table, merging table horizontally and vertically. And as questions became more complicated, if we want to put multiple queries and merge them, and its complexity would grow exponentially. For example, these prompt cluster relays from economical perspective based on the distance from nearest big city and their climate is kind of very big question, very complicated question, which would translate to several subqueries. One technology is LangChain to SQL, which is good for very small databases and very clean database schemas. But for this database, even for simple queries, it does not work. Okay, a solution. First, I think decomplexifying the whole domain is required. I should explain it with an example. If you are somebody which is familiar with electronics, you know that if you want to design any electronic, you need to know a basic of electronic theory, circuit design, circuit calculation, PCB design, circuit simulation, circuit assembly, and all of it is pretty hard. And it is both hard for human and both hard for LLM. There is another trend in the industry, which is modular electronic. In this trend, there are some standard components and there is one main board. You just need to know the components and just wire components to the main boards and upload the codes, and tada, you get the result. And even for somebody like me, which his major is not electronics, could build electronic systems. I think the same decomplexifying could be used, this decomplexifying pattern could be used in the data science. First, a standardizing component. Second, a standardizing interface. And the last is wiring component instead of designing the whole circuit. If you see this picture, you would see that there are standard ports and everything can be wired together through these standard ports. Okay, I should note that this is not something that invented by me. If you are familiar with software which name was Clementine or IBM SPSS Modeler, it's a low-code software for data scientists and some people like managers who are not familiar with coding could do their data research just by drag and drop and connecting the components to each other. But for this specific issue, which I had this specific project, I use these techniques. First, modularizing the items, the functionalities, having interface, and also wiring, which I'm explaining each one. I mean modularizing by writing a standard component with standardized inputs. By having a interface, I mean having a DSL, and by wiring, I mean using LLM for generating it. Okay. One trick which I used is separation of unstructured from structured reasoning. Unstructured reasoning is something that we want to know what users aims, and it is hard for conventional NLP tasks, NLP techniques to understand what user really wants. Structured reasoning is using rule engines like miniconran, or in this case Clara, to give us the or results, but it is really clear what we want. For example, if we have a chain of tables and we want to query between, for example, here between village and the province table. It is kind of an structured domain. It is a reasoning. It is not normal functional programming or object oriented. It is a functional thing, but it is an structured kind of things. On the unstructured, we want to understand the intention of the user. For example, I want a village name plus the province name of it. It is the unstructured thing which user is input. Or domain-specific language is as simple as a list of map. Each map has a type, and which could be select, filter, join, and etc. Each map could have sub-steps, and each steps could also have sub-steps as well. Processing start bottom up by using closure-walk. Closure-walk start from the leaf node or node which does not have any parent, and start step by step is build the whole data structure. And we use namespace function. We do not want to use the function itself, but we want to just generate the namespace from plus the function name. And based on the type of each step, different module would be run. Okay, one thing about this part, which I mentioned about namespace function, is that by using with closure, it is pretty simple to call namespace function. By just getting the keyword, you can generate the function and use that function. On the bottom, if you can see, this part could be translated to these lower parts. And it is another example. These table close select row data. I think I have a this type thing. Should say, what is it? Database. Okay. This would change to this map. The general workflow for it is a user prompts. Initial step is named entity recognitions. For example, it is really hard for LLM to understand very special names. For example, special names like Miami, maybe, or something. But when this pre-processing happens, it says that this name is plain. So when it's passed to the LLM would understand that it is plain, so it can reason correctly. LLM then generates outputs the high-level DSL, which is a map, which is a very abstract map. Then we use Clara as a rule engine to parse this abstract map to low-level DSL, which has it generate steps to solve the thing, and we start the post walk, and in each steps based on the low-level DSL, it would access the different modules or tools like this. Okay, I have examples which I'm not yet fully prepared, but I will push it up tonight, and you would see two examples which how this workflow would work. One is with a simple agent, the other one is with multi-agents. So I think it was pretty fast. So that's it. If I want to show you the notebook itself, show. Okay. Let's see. Yes. Okay. Here, later I will push this notebook. Here I create a Clara rule engine and define the data sets, schemas, demo some data sets, and based on when we want to do something like getting the results from village code and the province code, it starts joining the tables together. If I just show you, it could stand. Stand here. Okay. Here, as you can see, it can it is our DSL for joining the data sets, and based on the data set definition, start 2 and 2 columns. It automatically understand that it generates this DSL, and afterward is post walk is happening. Okay, here this post walk is happening, and when we have a map, it would do the inner join and build the total data sets. On this step, maybe you would ask why we need such overhead. In very small case like what we have, it is really killing mosquito with hammer. It is really have lots of overhead to do some 3 queries. But when you have huge amount of tables, it is really hard for data columns are separated between tables, and if you want to select the data in the first step, it's really saves lots of time. Okay, it's my presentation for now. I would share the link of my notebook up to the night, and that's it.
Thank you so much, Siavash. Yeah, Yeah, that's inspiring. And we have some time now, like 10 minutes for questions and discussion for this talk. And then later on, for people who can stay, we can keep going with all the other topics. And does anybody wish to ask anything about this talk of Siavash?
Yeah, I have a question. So in the overall workflow diagram, nice talk, by the way. Siavash, I'm interested in your thoughts about the step going from inputting the prompt into the LLM. So for example, doing standard NER stuff. And then from the LLM, you're suggesting that a high-level domain-specific language is being manifested. Let's put it that way. Can you unpack that a little bit? Because I think what really jumped out at me as being interesting was the idea of saying there's this high-level domain-specific language that has these complexities and maybe some vaguenesses and so on that are associated with it, that you're using them as constraints in a reasoning system, and then you're generating a low level or another domain-specific language, which is now matched to being able to orchestrate things like database calls and so on and so forth. But that step of saying LLM to high-level DSL and then converting that somehow or another into constraints, I'm very interested in your thoughts of how that works and ways in which that might be generalized to settings outside of the geo work that you're doing. Sorry for the long question.
What I think about it, first, it is I think it is a design pattern that even we as a human, when we want to solve a problem, first we are solving from the most abstract way of it. And then start digging in the more specific and understand it better. So it is the same technique that we human do, and it is not just for it is not just a technique for a low code, not for data science and low code. I think it is a general design pattern any engineer do. If you want to design a machine, for example, a factory machine, first we are designing the overall thing, then we are going to the specific detail, then we are, for example, analyze the stiffness, material, and so on. So I think the overall approach is something that is the same for any problem. But about specific about to LLM, I think they are really good at understanding very abstracting and abstract reasoning about things. But when they want to solve things very specifically, they make mistakes, and it's better we do not ask them for such a things. We do not ask them for designing the whole circuit. It is really hard for them. But if we ask LLM, these are the standard components, and you just decide what components are required and how to wire them, they are pretty capable of it. And one thing that I forget to mention that, and because this BI system would be used by top level manager of Ministry of Agriculture, I cannot nor any hallucination is not acceptable by the target customers. So they want their reports and they want to trust in the report. So this wiring has features that there is no chance that LLM make mistake on it. But normal, if you give them a list of numbers like what RAG solutions do, and then they process the result and give back to you, there is chance that they give you some mistakes. But these are my explanations.
Yeah, just to follow up there, in the specific example that you were showing here, are the constraints which are produced by the LLM as this manifestation of a high-level language, basically the named entities that have been extracted?
Yep. The name of entities that need to be extracted. So maybe let's see.
Yeah, I mean, actually, it's a roundabout way of asking, once you get an output from the LLM, what do you stuff into Clara? What's the input to Clara? How are those connected?
Yep. Let me maybe show you. First find the database table. And okay. Sure.
Let me just say that I think that it's an interesting thing to point at, that LLMs may be better or more trustworthy in being able to lay out the larger picture and using them as inputs to constraint-based reasoning is maybe a good way to sidestep a lot of the specific sorts of hallucinations. Or I can tell you one experience is the LLMs want to please, so they are happy to fill in explanations which are pretty much made up. But again, it's filling in those details within that larger framework that they usually get right.
Yep. In my system, as you can see my screen, there is a tables called tags. Tags are knowledge tags, and knowledge tags have relation with each other. So, for example, age, for example, gender population, female population, all of them are categorized under demographics. So these knowledge has relations with tables and also with columns. These tables and columns are imported elsewhere. And what LLM do in the first place, it understand what data are required, what tags are required, what filters, for example, users want to apply, for example, once year to year, something like it, and also what steps. So these are things that LLM is very capable of understanding it.
That's good. Thank you very much. Thank you.
Have you considered using Instructor? Do you know about Instructor? There is a library called Instructor, which does named entity recognition. I was wondering if you have had a chance to look at that, and if it sounds like at least like that's part of the problem. I don't think it's the entire problem. I feel like it's part of the problem. So I was wondering if you have had a chance to do that.
For named entity recognition, which is the first part before putting things to the LLM, I'm using SPACY because on my language, none of like Core NLP, Stanford NLP would work, and just SPACY has some package for it. So I'm using a Python SPACY, then get the result from the service and then pass it to the LLM.
Okay. Yeah, I don't know whether Instructor will work on Arabic. I have no idea. But we have a library called instructor CLJ, which we have written, which we use for English. It works very well to get structured output from unstructured data.
Could you share the name of it or link of it? Or is it open source?
It's open source. I'll put the link in the browser.
Thank you.
Yeah, Siavash, this is great. And maybe if that is okay, could you tell a little bit, if that's convenient, a little bit about the problems you're solving, about the actual domain where you're working?
I'm working on a project called, I should translate it in database of villages, and it is really huge database with lots of tables, and I do it as a donative project for the Ministry of Agriculture, and because of it, I couldn't use any other people to help on me, so I should do it with myself. And these limitations force me to find some maybe creative way to do what do they want. They want to query the whole database. They want to type what do they want from the data, and they get the reports in charts, in text, in Word documents, and in tables, and they would get the results. The data is not very clean, but I should maintain their structure, so I could not change the structure. And one other thing, that there are geospatial queries. For example, we want to know what is the economy, the mean average salary of village in the altitude of, for example, 1 kilometers above the sea. This is something that a bit strange. It's both has relational queries and both has geospatial queries, because you should because in the Postgres there is an extension PostGIS. You should have PostGIS extension. So this is the project.
Fantastic, thank you. Yeah, maybe one more short question to Siavash before we conclude this part. By anybody? Maybe I wish to ask you, what happens when the LLM part goes wrong? This part, which is relatively reliable, of just creating this high-level query, can we check that it is actually correct?
It is really hard to for 100% to be sure that LLM working correct. And before the DeepSeek, I was checking Cloud, ChatGPT, and all of them was not reliable. I mean, I asked them one question different times, and sometimes they get different response. They give to the same question different response. They give me different tags. For example, one times they mention economical, the other time they do not mention economical, and this really frustrated me. But after DeepSeek and its reasoning model, it is pretty reliable, and I didn't get any issues with DeepSeek, which I saw it. So I hope that it's working at least 99% of the time correctly.
Yeah. Oh, sorry.
Yeah, just to add, I use something called prompt foo for testing. It's very good. If people haven't tried it out, they should. It's a framework for evaluating your prompts.
Yeah, let me just add that there's things that can be done post response to check the coherence, do some sanity checks in a geo setting. Maybe it's just to check to see if there are lots of places that have the same name and they're in different parts of the world, for example. So injection of some kind of knowledge for sanity check afterwards is some way of handling it as well. Obviously, you'd like it to get it perfectly up front, but there's always the question of what sorts of guarantees are you going to give to your customer.
Yeah, thank you so much. Siavash, would you like to say something to conclude this part?
No, I think there are infinite ways we can use LLMs and agents to boost our productivity. I will share some of them in the notebook, but I think as much as you are creative, there are enormous space there.
Wonderful. We will now, in a moment, say goodbye to the recorded part, and which will be partially unlisted, and parts of that will be published on YouTube, depending on what the speakers choose. And what I'll propose we chat about in a moment is the coming meetups, what we want to do later on in the coming weeks and further, and how we can practice this together as a group, how we can learn more about the ways we use these existing libraries. And yeah, for now, we'll say goodbye to our listeners and see you on the next times.